Let's answer example 5-9. The rise of ocean due to hurricane. A hurricane is a tropical storm formed over ocean by low atmospheric pressures. As a hurricane approaches land, inordinate ocean swells bury high tides accompanied by hurricane. A Class 5 hurricane features winds in excess of 155 miles per hour, although the wind velocity at the center of the eye is very low. Figure 5.42, this one, depicts a hurricane hovering over the ocean swell below. The atmospheric pressure, 200 miles from the eye, this one, it's 30 inches Hg. At point 1, generally normal for the ocean, and the wind are calm. The hurricane atmospheric pressure at the eye of the storm is 22.0 inches Hg. So the eye of the storm at point 3, it is 22.0 inches Hg. Estimate the ocean swell at A, the eye of the hurricane at point 3, and B, point 2. Where the wind velocity is 155 miles per hour, take the density of seawater and mercury to be 64 pound mass per cubic foot and 884 pound mass per cubic foot respectively, and the density of air, normal sea level temperature and pressure to be 0.076 pound mass per cubic foot. So here's the given. You have the P1, P3, the velocity. This should be P3. Okay. Then the density of seawater, density of mercury, density of air at atmospheric pressure. Take note, the density of air changes depending on the temperature and pressure. The assumption is, of course, is steady flow, incompressible and irrotational. So we can use the Bernoulli equation. Now let's start with the solution. Okay. First, let's write the Bernoulli equation from point 1 to point 2. Okay. So point 1 and point 3 rather. Okay. So you have here P1 rho g plus velocity 1 squared 2g plus z1 equals at point 3 P3, okay, rho g plus B3 squared 2g plus z3. Okay. Now, take note that Z1 is our reference point in this solution. So that would be 0. Z3, it's actually that is H1. Okay. Now take note the velocity of point 1 calm, meaning there's no velocity of air, and also at the eye of the storm hurricane, it was assumed that there's no velocity, so that would be 0 and 0. So in this case, if we know the pressure at point 1 and point 3, we can determine the swell at point 3, that is H3. Okay. Now the equation would now be P1 minus P3 rho g equals H1. Now the given pressures are pressure 1, the given pressure is in terms of 30 inches Hg. Now take note that the pressure here should be in, convert this one into pound force per square foot. So you have to convert that. So don't just put this value here. So that would be a wrong solution. Okay? So let's we can convert it now. How to convert? Okay? Now to convert, you have the equation pressure, it's rho g h. Okay? If the height is in terms of hg, the density should be also in hg. Okay? The density of mercury is 848 pound mass per cubic foot. Now, take note that, for example, the pressure should be pound force. Now, if we just have pound mass per cubic foot, then the unit for G is feet per second squared. Then you have, this is height, feet. You might say that this one is now pound force, then cancel, this is, yan. Now this is wrong, okay? Because pound force, okay, is equivalent to slug feet per second squared. So remember this one. Okay, remember this conversion. Okay? So don't be mistaken here. So you have to convert the pound mass into slug. And you have 32.2 pound mass that is equivalent to 1 slug. So again, remember this conversion. Okay? Now, so with that, we can now convert the 30 inches Hg into pound force per square foot. So P1 now. So you have rho. What is the rho again? The rho for mercury should be mercury. It's 848 and the unit is pound mass per cubic foot. Again, convert this one into slug. So you have 32.2 pound mass per slug. Okay. Then rho, then the G is 32.2. So again, they're the same, but the unit is feet per second squared. Then the height is 30 inches. So this is in inches, so you convert that into foot. So that would be like that. So for P1, okay, let me check my answer. For P1, it should be 2120 pound force per, yan. So that's now P1. We only need to get the P3. Okay. Now for P3, the same also, 848. Okay. Now you understand what the solution before, so I don't need to add or multiply the 32.2. So we'll just make a shortcut. And this one, P3 is 22 inches Hg divided by 12. Okay. Then you have P3 that is equivalent to, okay, 1554.6667. Okay. Now, note, I will in our quiz, you should not you should save this one in the, or store this one in the calculator. Okay, no rounding off. Okay, during our quiz. Okay, no rounding off. Now with that, I could say that this P3, it's 4664, okay, divided by 3, that is pound force per big foot. Now let's go back to again to this equation. Okay, you have P1 minus P3 and rho G equals H1. Okay. Now take note, this one should be swell of water, so it should be in it should be the density of water. Okay. Now for the H1, that is now 2120 minus 4664 divided by 3. Okay. Then divided by the density of seawater, okay, 64. Now take note, always, this is now pound mass per cubic foot. Now always change this one into slug. So change this one slug, 32.2. Then, of course, you have the G, that is 32.2 feet per second squared. So that, because this one is, it's pound force per square feet. Now, this one, because it will not cancel out if you don't have the, this is slug. Because this is slug, feet per second squared is actually pound force. Okay, and this one is pound mass, so cancel, then you will be cancel, then what remains is feet H2O, or the swell. Okay, now the swell is H1 8.8333 feet. And that's the answer for letter A. Now, if you use this one for the next, to solve for the next problem or the next question, don't round it off, so I make it 53.6 feet over 53 over 6 feet. I will be inputting this one in the calculator. But if you write it in your solution, for decimal places. But if you use this one in your calculations to solve another problem, don't round it off. So you can store it in the calculator or here. Okay? So that's the number 1. Okay? Or the letter A.